Okay, now let us see some other polymerization reactions. Supposing if this is taken, when three molecules of, say, hexa-3-ine undergoes cyclic polymerization in the presence of Si2Cl6. See the extra part that we have in this particular molecule along with the regular acetylenic part is this, right? So that has to be shown along with benzene. This way, okay? Next. See, when this is taken into consideration, with HCl in the presence of ammonium chloride and cuprous chloride. Now, in this case, we get chloroprene. This simple simple thing is we have added HCl across the triple bond. Now, this is how we get 2-chloro buta 1,3-diene, right? Famously known as chloroprene. Now, even this chloroprene undergoes polymerization to form a polymer called neoprene, which is a synthetic rubber. Let me show you the polymer. Now, this bond comes from its preceding molecule, and see, during polymerization, this will go here, this will go here, right? And of course, something from the preceding molecule comes here. This is what polymerization is all about. C, Cl, double bond, CH, single bond, CH2 taken in time. Yes. Now the residual double bond is between the second and third carbon. Polychloroprene is neoprene. Neoprene is a synthetic rubber, right? Next, this is a linear polymerization reaction. Now, let us consider one more, some miscellaneous or other reactions. See, when acetylene is treated with HCl, it's a regular reaction. What happens? We'll get vinyl chloride. Look at CH2 double bond CHCl. This is vinyl chloride. See, even this vinyl chloride undergoes polymerization to form polyvinyl chloride. As usual, let me show the polymer this way. Okay. So this is PVC, polyvinyl chloride. Now, one more. See, acetylene reacts with chlorine. In this case, we get 1122 tetrachloroethane. Famously known as Westron. Westron. Now, when this is treated with alcoholic KOH, a dehydrohalogenating reagent, right? Then, of course, remove HCl, one molecule of HCl, and you'll end up with CCl2, a fresh bond between the two carbons, then CHCl. You can simply say trichloroethylene, or of course 112 trichloroethene, famously known as Vestrazole. You know, Vestron and Vestrazole are solvents used in dry cleaning. So that is the reaction with the chlorine. Now, let us take the identification test. First one is tolerance test. Test with the tolerance reagent. You know, ammonical silver nitrate solution is called tolerance reagent. Right. What do you mean by ammonical silver nitrate? Silver nitrate along with ammonium hydroxide. Or this can be shown as AgNH3 taken twice OH in the form of a complex called diamine silver 1 hydroxide. Right. Now this is tolerance reagent. Consider an alkyne with acidic or active hydrogen. Let me say alk1ine, or in general terminal alkyne. So this of course is acidic or active. Hydrogen, because it is attached to sp hybridized carbon with ammonical silver nitrate solution. Acidic hydrogen is simply replaced by the metal to form a white precipitate of silver acetylide. Okay. White precipitate of silver acetylide is what we get in this. Now the second test is with the ammonical cuprous chloride solution. Even here also, the presence of acidic or active hydrogen is necessary. Only then you get the reaction. In this case, consider cuprous chloride along with ammonium hydroxide. That is ammonical cuprous chloride solution. Just like in the previous case, here we get red precipitate of copper acetylide. Okay. Color of the precipitate is important. See, these tests are of course given by only by, let me say, terminal alkynes. As I said, only those with the acidic or active hydrogen. So if you consider things like this, yes, it can, because it has acidic hydrogen. Now, if this is considered, even this also has an acidic hydrogen, so it's okay. But if this is considered, then because it has got no acidic hydrogen, it doesn't give. Okay. These are the identification tests for alkynes. Let us see how to distinguish alkanes, alkenes, and alkynes. Now, let us take alkanes, alkenes, then alkynes. And the first test that we are going to consider is bromine in CCl4 test, in which orange red color of this particular solution disappears. Discussed already. Okay. Now, alkanes do not respond to this test. As discussed already, this is a test for unsaturation. Only alkenes and alkynes, I mean only those with unsaturation give this particular test. Right. Now let us go for test with Bayer's reagent. Cold dilute alkaline potassium permanganate. In this case, pink color of the reagent disappears. Right. Even this also is given only by alkenes and alkynes. All types of alkenes and alkynes. Now, test with the Tollens reagent, wherein we get white precipitate. Okay. Even this also is not responded by the alkanes. Just leave them. Even the alkenes do not respond to this test. Of course, alkenes respond, but conditions apply. Star. What is that star? Star refers this thing. Only terminal alkynes respond to this test. Just discuss. Then finally, the test with ammonical cuprous chloride solution. In this case, we get a red precipitate. No reaction in case of alkynes. Even for alkenes, alkanes no reaction, alkenes no reaction. In this case, again, it is the same with star. Again, only the terminal alkyne. That's it. So that is how we can distinguish alkanes, alkenes, and alkynes. Okay. Guys, with this, we